Hi, in this video we will look into quicksort, shortly known as qsort. In qsort, the first thing we should do is partition. So what is a partition? As the name says, the aim is to split the list into two halves. So how do we do it? We have something called as a pivot, which can be any object in the list. It can be the first element, or it can be the last element, or it can even be the randomized selection. So for convenience, I'll fix the pivot as the last element. We need to do some operations such that everything to the left of the pivot will be lesser than it, and everything to the right of the pivot will be greater than it. So for this, we maintain two pointers, say I and j. The one in the left is I. I compare the ith index with pivot. If it is less than it, in this case it's 4 is less than 5, I move the ith pointer to the right, that is I plus plus. If the ith element is more than pivot, like in this case 7 is more than 5, I swap the ith and jth index elements and shift j to the left, that is j minus minus. Next, 6 is more than 5, swap j minus minus. Again 9 is more than 5, so I swap those both and I do j minus minus. 1 is less than 5, I plus plus. 2 is less than 5, again I plus plus. 8 is more than 5, swap j minus minus, and so on. I do this till I is less than or equal to j. When I becomes more than j, then we can find a position to fit the pivot such that the below condition is satisfied. That is, in this case, I swap the ith position element with the pivot, and I notice that everything to the left of 5 is now less than or equal to 5, and everything to the right is more than it. Now we have a sub problem to solve, that is, the left subarray and the right subarray can be solved independently by making another partition. So this is a pseudocode for partition that we have seen. Partition of A, left and right. I and j is left and right minus 1. Pivot is the rightmost element, while I is less than or equal to j. If A of I is less than or equal to pivot, then I move I to the right, I plus plus. Else I swap AI and AJ and I do j minus equal to 1. When the loop gets terminated, we can swap the pivot with the AI position, and we notice that below mentioned properties before is satisfied. I return I, that is the position where I have shifted the pivot to, and now we can make a pseudocode for quicksort, that is, till left is less than right, I make a partition on A, left and right. I get the position where we have put the pivot, and I make a recursive call to this function by saying A left j minus 1, that is the left subarray, and quicksort of A j plus 1 right, that is the right subarray. After everything is over, we get A to be sorted. In the previous slide, we have seen a in-place algorithm for partitioning. Can this be done out of place also? Yes, it is easy to see it, and it's pretty straightforward also. Next, the most important part, time complexity of qsort. The average time complexity is expected to be order of n log n. That is because each partition is order of n. That is because we have I and j in the left and to the right most ends, and we start moving till they become equal. In simpler terms, we are traversing to each element of the array, so it's order of n. And if we find a good pivot, we have good half of the list, so yeah, it's order of n log n. But the worst case complexity is still order of n square. This is when the pivot is supposed to be in the last position all the time. So I am done for now. Thank you for watching the video. Hope you found